I next want to talk through a set of slides that illustrate some of the ideas about R squared. So if you look at these three examples here, picture 1, picture 2, picture 3, they're all drawn on the same scale, so the x-axes and the y-axes are identical. And in each of them, what I'm starting out by showing you is the mean in each of 4 groups based on x. So x is some variable, some predictor variable that could be equal to 1 or 2 or 3 or 4. And what I'm showing you here is what the mean of y is going to be for people who have x1, what the mean of y will be for people of x2, etc. And then 3 different versions of this picture. So for example, in this graphic, you can see that when x is equal to 1, the mean of y is a little bit over 2, right? And when we get all the way up to x equals to 4, the mean of y is maybe right at 3. But in this data set, let's go all the way to the other extreme. When x is equal to 1, the mean of y is almost down to -2, and when x is equal to 4, the mean of y is right around 7. So those are the 2 sets of means we're thinking of. And what I've done first is I've literally taken the mean of these 4 y values. No, we've taken the variance of these 4 y values, not the mean, but the variance. The y values each represent a mean. So if I take the variance of this value, this value, this value, this value, right? So it's like 2.1, 2.2, 2.7, and 3, something like that. The variance of those values is 0.1. If I take the variance of these 4 y values, I get 1.88. And if I take the variance of these 4 y values, you get 13.7. Right? So that shouldn't be shocking that those numbers are so different. It's the variance of the y values. Remember that those y values are supposed to represent the mean of y given x. So what I've done now is I've added variance to each of these. Right? I've added variance to each of these. So I've actually added the same amount of residual variance. So for example, when x is equal to 1, this red dot represents the mean of y, and the black dots represent the actual data points for people who have x equal to 1, right? So they vary around that mean. When x is equal to 2, I've added the actual data points, so they vary around this red mean, and the same throughout. And I've done this so that the residual variance is set to be the same amount, not only within each picture, so for these 4 groups, but also in each of the 3 pictures, the residual variance is set to be the same. So my question for you is, which of these pictures has the largest R squared? The first picture, the second picture, or the third picture?